Finally, for this worksheet, we have to remember the beginning of this worksheet. It was titled Plane Figures and Solids. So we're now going to talk about solids. We talked about all of our plane figures. Now we need to understand that a solid is a figure that lies in space. So we need to understand the difference in a plane figure and a solid. So remember, space is like everything. So imagine anything extended in every single possible direction. So imagine exactly where you're sitting. Imagine busting out the floor, the ceiling, all the walls, the ground goes away, and you're just hanging there. And it's extended, like think of Earth. It literally hangs out in space. We're not talking outer space here, but same idea. So you get rid of all your walls. You can go forward, backwards, up, down, every possible diagonal. That is space. Okay. A plane, imagine exactly where you're sitting and everything getting busted out, the floor, the ceiling, the ground, all the walls except for one wall. And that one wall can extend in two directions, so up, down, and then left, right. So kind of think of a plane having length and width, but it extends indefinitely. So the length extends indefinitely, the width extends indefinitely. Okay. So when you're dealing with a plane figure, it's a flat figure. It has length, it has width, it has no depth. When you're talking about a solid figure, we're now talking about something that can live in three dimensions. It can have length. It can have width. It can also have depth or height. Okay. So it's literally three-dimensional. It's solid. You can hold it. It extends in lots of directions. Okay. So it's no longer flat. It has substance. Okay. So again, a solid is a figure that lies in space. Solids have length, width, and either you can think of it as depth or height. Okay. So all we're going to do here is just kind of name common solids. Okay. So the first one we have here is what we call a rectangular prism. And if you look at the front of it, we have our length. Whoa, why is that doing that? Okay, there we go. So we have a length, we have what we typically call a width, but now we have depth. So it's kind of like this rectangular that we have here, but we've extended it back. So imagine a 3D printer that makes the face of this rectangle and then keeps building it up. Okay. So we no longer just have length and width. We now have this idea of depth. Okay. So depth. You'll sometimes call it length, width, and height. It just kind of depends on what you want to name it. So you could also name this length, width, and then you could think of this as height. Okay, so it just kind of depends on how you want to think of it, but now there are three dimensions that we're dealing with. Okay, and then we have over here, whoops, we have over here a cube. Okay, so a cube is a special type of rectangular prism where the length, the width, and the height, or the length, the width, and the depth, if you want to look at it that way, are all the same. So you start with like the face of your cube. Okay, so we've got our cube that has a square face, but now we have this depth that goes back in this direction, and it's going to have the same. So we have our length, are you'll sometimes think of this as your width and this is your height, whatever. I don't really care. So you got your length, width, height, or you can think of it as length, width, and depth, same difference. But what you need to understand here is length is equal to width is equal to height. Okay, and that's a little bit different than a rectangle because in a rectangle, length, width, and height, or length, width, and depth can be totally different measures. With a cube, they're all exactly the same. All right. Next up, we have a pyramid with a square base. Well, I don't want to say square. I'm going to say with a rectangular base. That'll be a little bit more accurate. With a rectangular. You could have a pyramid with a triangular base. So just know that you could really have any. I like this pyramid with the square base. So that's what we're going to work with. Okay. Next, we have a sphere. So a sphere is a little bit different. It doesn't have length, width. It has a radius. And then it kind of has length, width, and depth, but we can't measure them the same way we can with these rectangular prisms. Okay, but it's definitely three-dimensional. Okay, it's not flat. It's not a circle. It has oomph. Okay, it's got this roundness. It's got this third dimension to it. Okay, and then that leads us to the last two. So for part E, we have what's called a cylinder. All right. And then the last one is a cone. Okay, so if you take a cylinder and you kind of shave it all around, so you start with a point at the top, the center of your circle at the top of the cylinder, and then just kind of shave around it, you end up with a cone. Okay, same thing with this pyramid that has this rectangular base. You start with a rectangular prism and you start shaving off the corners, and you end up with a pyramid. Okay, so all of these are three-dimensional figures. Okay, the easiest way to think of this is length, width, and depth. Okay, even though some of these don't necessarily have a length and a width, but still kind of envision like length, width, and depth. Okay. So in future sections, we're going to talk about perimeter, we're going to talk about area, and then eventually we'll get back to these solids and we'll talk about volume. So we may not see these solid figures for a little bit, but they'll come back towards the end. Okay. So that is plane figures and solids. You know what they look like. When you're dealing with the solids, a lot of times we'll talk about a base again. So like with this pyramid, the thing it's sitting on is its base. The cylinder, the thing it's sitting on is its base. The cone, the thing it's sitting on is its base. We'll talk more about those formulas and stuff when we get to them though.